Okay, good afternoon all of you. In today's session of class 12 chemistry, we are going to continue with electrical properties of solids. So suppose you have a given sample of silicon, a given mass of silicon. So in that what will happen, every silicon atom will be covalently bonded to the four neighboring silicon atoms. So this silicon will be covalently bonded to this one, this one, this one and this one. Now you know that in every covalent bond there are two electrons. So when silicon is bonded with this or this, so each bond has two electrons. Now what happens is that due to some thermal agitation, it is possible that some electron it may just come out of its valence shell, or it may come out of the covalent bond. That means it has come out of the valence band. And if an electron comes out, we will show it like this. So if an electron comes out, we will show it like this. We will just draw these dashed lines. So dashed line means the electron has come out of the bond. And you know that in a covalent bond, when electron is present, that means that electron is in the valence band. And after it comes out, then it becomes conduction band. Now that means due to the coming out of this electron, you have one free electron. On top of that, over here there was an electron, now there is nothing. So this place is called a hole. And every time there is an electron, there will be a hole. So electrons and holes will be in pair. Now it is possible that to fill up this hole, another electron may leave its bond and go there and fill up the hole. So suppose if an electron goes from here, then what will happen is that over here you will have a hole, and over here this hole will get filled up. So if an electron comes out of its bond and goes over here, then over here instead of a hole you will have an electron, and now the hole will come here. That means the movement of electron is opposite to the movement of hole. The hole has come out of this bond and, the hole is going into this bond and electron has come out of the bond. But the problem is that this quantity of electrons and holes is very, very small, and it is not enough for significant amount of conductivity. So to improve the conductivity, what we do something called doping. Okay. So if you take any element of group 15 of the periodic table, if you take any element which belongs to group 15 of the periodic table, so you are aware that group 15, all of them, they have 5 electrons in the outermost shell. So suppose if you take an element like phosphorus, a typical group 15 element like phosphorus, so it has got 5 electrons in the outermost shell. So the 4 electrons will be involved in bonds with 4 silicon atoms, and the 5th electron, it will revolve around the phosphorus nucleus with a very large radius. So in the phosphorus atom there are 5 electrons in the outermost shell, and out of 5, 4 will be involved in bonds with 4 neighboring silicons, and the 5th one will revolve around the phosphorus with a very large radius, because it is not a part of the bonding. So this 5th electron, it will behave like a 5th electron, it will behave like a free electron, and every phosphorus atom will contribute one free electron, so that will drastically increase the conductivity. So that explains how addition of, so this technique is called doping. Doping means addition of an impurity. Why do we call it impurity? Because compared to silicon, the quantity of phosphorus will be very, very less. So the addition of a group 15 impurity will enhance the conductivity significantly, because every atom will increase the number of conduction electrons by 1. Now the majority carrier in this case will be electron and not hole, like in the previous one. So this is natural silicon, so we call it intrinsic. Intrinsic means natural, and this is artificial, so this we call it extrinsic. So in an intrinsic semiconductor, the number of electrons and holes will be equal. In an extrinsic semiconductor, you will have much greater number of electrons because of the pentavalent nature of the impurity atom. So extrinsic, this is called N-type semiconductor. Why is it called N-type? Because it is majority carrier is electron, which is negative. So this kind of semiconductor which is doped with pentavalent impurity is called N-type semiconductor. Similarly, if you do doping with group 13 element, so group 13 element. So if you have a group 13 element like aluminium, suppose you have a group 13 element like aluminium. So aluminium is trivalent. You know that aluminium has got 3 electrons in the outermost shell. So aluminium atom is covalently bonded with silicon, 4 neighboring silicons. So at the side of the third bond there is a hole, because you know that it is trivalent. So at the side of the fourth bond there won't be any participating electron from aluminium. So that is why it is called a p-type semiconductor, because the majority carrier is the positively charged hole. And this is also an example of extrinsic semiconductor. So this is also an example of extrinsic semiconductor. So the majority carrier is the hole, and it is called p-type because the majority carrier is hole, which is overall making the semiconductor positive. So this is the concept of intrinsic, extrinsic n-type and extrinsic p-type semiconductor. Now your homework is that you will have to draw this type of diagram for the extrinsic semiconductor, in which silicon plus gallium and silicon plus arsenic. Okay, you will have to first look at the periodic table and decide that gallium and arsenic is in which group. You will have to decide that gallium and arsenic, is it pentavalent or trivalent, and accordingly you will have to draw the extrinsic, whether it is n-type or p-type, for silicon plus gallium and silicon plus arsenic. So this will be your homework, and you can submit and finish the homework by 9 p.m. tomorrow, that is Monday. That will be all by all of you.